Hello everyone, this is me, Ibrahim Absalam. Today I will talk about timers in Siemens LOGO. The timer library can be found in special function timer. Okay, the first timer we call it on delay. This is one of the most important timers. From its name we can understand how it works. Once it triggers, it stays for a delay time and then its output become high. Once the trigger signal removed, the output will become 0. Okay. If the trigger signal come but stay for time less than the preset time, the output will keep 0. To have better understand of how this on delay timer work, we can do some simulation on logos of comfort to understand how the timer works. So we add a new diagram. Okay, just drag an input and one output, and we need and from special functions select on delay. I will zoom to have to see it. Okay, connect input to trigger and the output to Q. That's it. Okay, let's simulate. Double click on the timer block. This is the here the on delay. It can be in seconds, in minutes, or in hours. Okay, so we can make the on delay 5 seconds. Let's simulate the timer to understand how it works. Press simulation button. Just activate the switch. You can see here the timer start counting until it reaches 5 seconds, then the output become high. Turn off or that is off, the output is off and the timer is waiting for another set. Okay, let's press again for 2 seconds. Now off. Before the time off, the output still 0 and will hold, and the counter reset itself. The timer reset itself. Okay, if we activate the pretend feature, just increase the time to 10 seconds to make it easier for me. Okay, I activate and then power off the logo. If the power come back, the counter will continue from the its base value. Even if you move to stop mode and run again, the timer will continue count. Okay, this is regarding to the on delay time. Off delay timer. How it works: once the rising edge of the trigger happens, the output become high. When in the falling edge of the trigger, the timer start count the time for certain time t. Okay. Another scenario: if you have a trigger high and then low, but the high again happen in time less than the trigger at the preset time. So the output will keep the high and the counter will reset and will recount again once it's off again. Okay, to simulate it, to have better understanding, we need to simulate this one. Start. I will delete this. Sorry, go to work mode. We drag and drop off delay timer. That's the trigger, and here it's output. Double click on the timer block. We make the off delay for 5 seconds. Simulate. Okay, once it's high, it's high. Once it's low, the counter starts count, and after just 5 seconds, it will become low. Okay, high. Once the trigger signal receives, the output immediately become high, and once off, the counter start counting. Okay, trigger again. Okay, the output kept high until it released and it will keep high until it takes the preset time. Okay, another timer is called on off delay timer. Here is it. Double click. It has on delay 5 seconds and off delay of 5 seconds. Okay, let's see how it works. Once it's triggered, it will delay for 5 seconds before it become high. The output become high, and when the trigger signal removed, it will delay the off for 5 seconds. So it's a combination between on delay and off delay. We have now retentive on delay timer, where the trigger signal and output. Double click on the retentive on delay, which will, let's give it 5 seconds. Okay, simulate it. Once it's triggered, once the signal removed, it will continue counting until it reaches. Okay, trigger again, never stop. So how it turn it off? It must receive a reset signal. So we need from here an input, another input switch to give a reset signal. A reset signal. Simulation. Momentary push button. Okay. So it's counting. After 5 seconds, the output is high. When the reset pressed, the output becomes low and the counter and the timer reset itself. The whipping timer or pulse output, once that it's triggered, it gives a pulse of a certain time. Once and then it becomes 0. Okay, if the pulse is less than the time, it gives high and then becomes 0, and the timer will reset itself. Okay, let's see how it works. That's a whipping timer. That's input, trigger, output, and double click on the timer. We make it whipping of 5 seconds. Simulate it. High, 0, it reset. Okay, high. It will keep high for 5 seconds and then off. So you get a pulse of 5 seconds. Okay. Each triggered whipping relay. This relay are used to generate a train of pulses with certain on period and off period, and it can repeat itself. Let's say, for example, to understand how it works, better to see each trigger whipping. So we have a trigger and we have our output, and double click. Let's say T high, time for high is 5 seconds, time for low is 2 seconds, and number of cycles I want to repeat this sequence for 3 times. Okay, generate. I just trigger it. It will continue. It will generate 3 pulses. You can see on, off for 2 seconds, on for 5 seconds, off for 2 seconds. Exercise 1. A 3-phase induction motor with an external cooling fan operates as follows. Once it receives the start signal, the motor and the fan contactor immediately activated. Once the stop signal received, the motor immediately stops and the fan will stop after 1 second. Draw the function block diagram of the system that performs the above process. Okay. As usual, we need to know how many inputs and outputs. In this case study, we have 2 inputs, the start signal and stop signal, and 2 outputs, the motor and the fan. And off delay timer will be used to control the fan. From this circuit diagram, right click and choose properties. I/O names, name element start, I1 start, I2 stop, Q1 motor, Q2 fan. Okay. This is the start signal, stop signal, and we have 2 outputs, Q1 motor and Q2 is the fan. We need 1 AND gate and 1 OR gate. Let's fire everything now. We have our batch, and double click here. Okay, the fan output will be first attached to an off delay. Just to make the simulation easy or don't take much time, I will make the off delay instead of 6 seconds, I'll make it 10 seconds. Okay, let's simulate this program. The start signal received, both fan and motor are now running. The stop signal received, the motor turned off immediately and the fan will wait for 10 seconds to be turned on. Okay. Exercise 2. Consider the problem zebra crossing. Draw the ladder diagram of the system. The zebra crossing is working according to the following sequence. At the beginning, the green lamp is turned on and the no passing lamp is on. When a person presses on the passing button, the yellow lamp is turned on for 3 seconds. Then the red lamp turned on for 60 seconds. But after 5 seconds, the passing lamp is turned on for 20 seconds and the no passing lamp will activate it again. Okay. After the time delay of the red lamp, the yellow lamp will turn it on for 3 seconds. Then the green lamp is turned on again. The process will not repeat it before 100 seconds pass. Okay. Before solving this program, we had to recognize how many inputs and outputs we have. Now if we have a closer look, we have only one input is the passing button and 5 outputs, the red lamp, green lamp and yellow lamp, and passing and no passing lamp. So we have 5 outputs and 2 inputs. Okay, we can make a nice trick before writing our program. The relation between the green lamp and the yellow and red lamp. It's not accepted to turn on the green and yellow at the same time or the green and red at the same time, so I will make a complement. So to turn on the green lamp, will turn it on in case of the red and yellow are off. Same thing on passing and no passing. If the passing lamp is on, the no passing lamp will turn it off. If the no passing lamp is on, the passing lamp will off. This tricks will help us to simplify our program. Let's go to our ladder diagram. From properties, IO names, name everything. I1 is button, or that Q1 is the green, Q2 yellow, Q3 red, Q4 passing, Q5 no passing. So to start our program, the user will press on the passing button I1. I will need to memorize this action, so I will add it to a latching relay. In a latching relay, I will use a latching relay to keep this action. So it will set this latching relay. Okay. At the beginning, the green lamp is on and is on, and no passing lamp is on. Okay. This is our green lamp. This is our yellow lamp, and this one is red lamp. Passing, no passing. Okay. So to satisfy the first condition, the green lamp is on and the no passing lamp is of Q2. Add a break Q3 or red, and we need another break Q4. So if we look to this part of program, it's very easy. The green lamp will only turn it on if the red and yellow are off, and the no passing lamp is on if the passing lamp is. I satisfy the first line. At the beginning, the green lamp is on and no passing lamp is on. Okay. When a person presses on the button, on the passing button, the yellow lamp is turned on for 3 seconds. Okay. Okay. The user press on the passing button. This button is activated. So a special function block 001 will be high. So I need to turn on the yellow lamp. Special function block. The yellow lamp is turned on for 3 seconds, so I will use on delay timer, and I put it's on delay 3 seconds. Okay, and it will activate it once the yellow lamp is on. Triggered. Okay, once the timer finish, it will cut the power from the yellow lamp. Timer 2. So by this way, the yellow lamp will turn it on for 3 seconds. Okay. Then the red lamp is turned on for 60 seconds. Okay. So at the same time, timer 2 will turn on the red lamp for 30 seconds. So I will need a normal contact here. It will be timer 2 on delay. Okay. This will turn on the red lamp, and I will use one more of delay timer. 30 seconds of delay timer. And timer 2 will trigger it also for 30 seconds. Once the 30 seconds finished, I will turn off the red lamp. Okay, so I will add a break here from timer 3. Okay. Let's continue step 3. The red lamp is turned on for 30 seconds, but after 5 seconds, the passing lamp is turned on for 20 seconds. Then no passing lamp will activate it again. So to do this function, we need to generate a bunch start by on delay by 5 seconds. So the best one we can use is the edge triggered with webbing relay. This one called timer 4. Okay. Timer 2 will do many tasks now. It will turn on the red lamp, activate timer 3 for 30 seconds, and activate the timer 4. Okay. Double click on timer 2. We need to the high time is 20 seconds, and it start after 5 seconds. Timer 4 will activate once it's high, it will activate the passing lamp. So we need to add timer 4. Okay. After the delay of the red lamp, the yellow lamp will turn on for 30 seconds. Then the green lamp will turn it on again. Okay. Timer 3 is 30 seconds. Once it's finished, it will turn off the red lamp and it will turn on the yellow lamp again. So we just need to move this stuff downward a little bit. So timer 3. Timer 3. So timer 3 will turn on the yellow lamp, and we'll have timer 5 of the on delay timer for 5 seconds to turn off the yellow lamp again. And timer 5 will timer 3 will activate it also. Timer 3. and this timer for 3 seconds. Okay, and timer 5 will turn off the power from timers from the red lamp. Turn off red lamp. Okay, the next final step. This process will not repeat it before 100 seconds pass. So timer 5 will activate 100 second on delay timer. Then we reset the latching relay from timer 6. So we'll have one more line. Timer 5 will activate another on delay timer of 100 seconds. Call it timer 6. To make the simulation faster, I just make it 30 seconds. Timer 6 for 100 seconds. Timer 6 will reset this set reset button. So I will add a contact here, call it timer 6. When I try to connect it, there is a restriction here. I'll not allow it via output and flag. So to overcome this issue, I will use internal memory. So timer 6 will write 1 in internal memory. We have here timer 6, double click here. I will, let's say, M2 flag. I will use M2 flag to reset this button. I select memory 2, and I will add a contact here. It will be memory 2 and connect it to the reset and finish. Okay, now let's simulate our program. Press the simulation button. In the beginning, as we expect, the green lamp is on and the no passing lamp are on. So the green lamp is on and the no passing lamp is on too. Okay, what we expect, once we press on the passing button, the green lamp will turn it off and the yellow lamp will turn it on for 3 seconds. Okay, immediately turn it on and the timer start count. The red lamp is now off, the yellow lamp off, and the red lamp is on. After 5 seconds, the passing lamp is now high for 20 seconds. No passing, and the red lamp will keep on for 5 more seconds. Then the yellow lamp will turn it on again. Yellow lamp is turned on again for 3 seconds, and then the green lamp is on. Okay, if the user tried to activate this process, it will not repeat it until the last timer 6 collapse or finish count. So it's now 20 seconds. We'll make it 30. So the process will not repeat it until the 30 second finished. As you can see, nothing happened. Now everything reset. Okay, you can see the process start to repeat itself again. Okay, thank you for watching and goodbye.